Hey guys, we're going to start off with another transformation here. So remember that we said that this omega part has to be greater than zero, and we got an issue here because it's not greater than zero, it's negative, but we can fix that since the sine of negative theta equals the negative sine of theta. We'll just use that here and we'll carry that negative out in front. So we'll change to y equals negative 4 sine pi over 4 x. Okay, so now we can use, we're going to find our amplitude. It's going to be the absolute value of negative 4. So 4 is our amplitude, and our period, t is equal to 2 pi divided by omega, which in this case is pi over 4. Okay, so that's going to be like 8 pi over pi. So we're going to end up with 8 for our period. Okay, now over here, remember what we've got graphed is just plain old y equals sine x, and the key points that we're going to transform are those 5 key points. So remember, we take x divided by omega, and then for the y's, we take the negative 4 and multiply the y's. Okay, so and omega is pi over 4. A is negative 4. All right, so we're going to have a 0 divided by pi over 4, which is still 0. And then the negative 4 times 0. Okay, so that's for this guy. So that's going to stay 0, 0. Okay, next point, we're going to take pi over 2 divided by pi over 4. Okay, so that's going to be equal to 4 over 2, or 2. And then we're going to take negative 4 times 1. So our new point for this is going to be 2, negative 4. Okay, got that one, got this one. Now we're going to take pi and divide it by pi over 4. So that's going to equal 4. And then negative 4 times 0. So that third one's going to be 4, 0. Okay, fourth one, so we got that. Fourth one, I'm going to take 3 pi over 2 divided by pi over 4. Okay, you can see the pi's are going to keep canceling out here, so we're going to get 12 over 2, or 6. And then when I take the negative 4 times negative 1, we're going to get positive 4. So the third coordinate is 6, 4 transformed. All right, this last one, out of room down here, so I'll do this one up here. I'm going to take the 2 pi, divide it by pi over 4, which equals 8. I'm going to take the negative 4 times 0. Okay, so this last one is going to end up being 8, 0. Okay, so I've got the new 5 points for my transformed version. All right, so if we plot those 5 transform points, 0, 0, 2, -4, 4, 0, 6, 4, and 8, 0, we've got a full period of this transform sine. So if I go 8/4, that tells me how far I need to go from one key point to the next. So for instance, we know here is 0, and if I go back by t/4, -2 is the key point that precedes 0, 0, so -2, 4. And then if I go forward by 2, I know that 2, -4, and so on. So that makes it a little bit easier once we've got this piece done to go in either direction and calculate, and we know where it'll be. We know that the next key point from a new beginning of a new cycle, the next key point goes down over 2 and down 4. So I would go over here. I'm at 16, 0, so I know that at 18, I'm going to be at -4 again. This is the next point that's going to happen. And notice that that is a full period from the last point in that location. So we go t divided by 4 to get to a next key point, but we go from a key point 8 for a full period to the next key point in that cycle that matches. Okay. And looking at this next example, can you recognize how it's different from what we've done so far? So our beginning function is just the plain old cosine x, but we've got an omega that's equal to pi, and we've got an a that's equal to -4. And then it says subtract 2 from that result. So what we need to do is start with this chunk here, and we'll deal with the -2 later. Okay, so taking that piece out, we know that the amplitude, the absolute value -4, so it equals 4. Now a is -4, but the amplitude is the absolute value, so that's 4. The period is equal to 2 pi divided by omega, and omega is pi. So 2 is our period. And we know that we have to take the original coordinates of the cosine, and we're going to take each x and divide it by pi. And then for y, we're going to take -4 times y. Okay, we call that our modification, or our key points mod. The key points that we'll start with for the regular cosine is going to be the 0, 1, pi/2, 0, pi -1, 3 pi/2, 0, and back to the 2 pi. Okay, so if we remember that omega was equal to pi, a was equal to -4. So we're going to take and make this new point. I'm just going to do this a little quicker than we've done before. So 0 over omega is still 0. -4 times 1 is -4. Pi/3 divided by pi. Oh, we're not doing that one, sorry. Pi/2, and then we're going to divide it by pi. So that's going to be 1/2. And the -4 times 0 is still 0. Skipping down to this one, we've got pi/pi. So pi/pi is going to be 1. And then we're going to take -4 times -1, so that'll become a +4 there. And then for this one, the 3 pi/2 over pi is going to be 3/2. -4 times 0 is 0. And for this last one, 2 pi/pi will be 2, and -4 times 1 will be -4 again. remember that t was 2, the full period was 2 to get from the start key point to that same place was 2. So divide those into the quarters. It's 1/2. So I can step 1/2 from any key point to get to the next key point in sequence. Okay, so these are the key points that we've transformed, but remember we only took care of this part, right? The function that they gave us also subtracts 2 at the end. So what we're going to do is we're going to go ahead and plot the refigured key points for this cosine. And it's going to look like this first picture here. So we've got these plotted, and then we can fill it out by stepping 1/2 left or right, and then it's going to take us to the next one in sequence. So if I'm at a 0, -4, if I go by 1/2, I get to a 1/2 0. And if I go by another half, I get to the top of the cycle. And then by another half, I'm back down here, and another half here, and so on. So we can take that and extend it a little bit and then put our little arrows when we think we've got enough. But now we have to take care of this. And all that does is shift the graph by the direction. So this says drop my y by 2 because we're calculating y here, right? Y equals this. So we gave them that. And then it said, after you get that, I want you to subtract 2. So that's going to take all of our y's down 2. So all I have to do is subtract 2 from every y here. And so that's going to end up looking like what we got over here. Okay, so now we've done this. So this is the full picture for y equals -4 cosine pi x minus 2. And now what we should do is determine the domain and the range here. So the domain is still the same. The domain goes from -infinity to infinity. But if we look at the range, because we shifted down 2 units, if this had been +2, we would have bumped every point up and added 2 to y. It's subtracting, so we drop 2. And we can see now that we've adjusted our range. So the lowest value for the range is -6. And then up top here, the highest value for y is 2. Okay, so same domain, but the range is now -6 to 2. Okay, in this next case, what if we're asked to look at a graph and then try and figure out what function creates it? So in this case, since the graph starts out at 0, 0, it looks more like a sine, because remember that if I were a cosine, I'd start up somewhere up here and then loop down for my cycle. Okay, so let's try and represent it with a sine. And we also recognize that a period takes 4 units in order to create. Okay, what we've said already is that the period is equal to 4. And we know that 2 pi divide omega is how we calculate the period. So 2 pi over omega is 4. So that means if I multiplied both sides by omega, I'm going to get omega equals pi over 2. Okay, if we solve this for omega, multiply both sides by omega, we have 4 times omega. 2 pi is equal to 4 times omega. Divide both sides by 4. 2 over 4 reduces to 1/2. So that becomes pi over 2 equals omega. Okay, so omega equals pi over 2. Now, they also tell us here the max of 2 occurs at x equals 1. So the absolute value of a is going to be equal to 2. Okay, so we're going with a sine, and we have absolute value of A is 2, and our period is 4. So we know that this has to be a positive 2, because if we split that period into its 4, we go 1. So here's our sine of 0. And then if we go 1, that's 1/4 of the period. So we know that's where we get the next point. And the graph shows us that that's a positive 2. So we can now determine that y is equal to 2 times the sine, and omega is pi over 2. So pi over 2 times x. Okay, let's look at a new graph. We'll do that again. We can see again that we're suspecting a sine function here since we got 0, 0. But look how it's flipped. So that means that our A this time is going to be negative to draw that down, because we look at our period. To go full period, we had to go 8. Okay, so T is equal to 8. And if we split that into quarters, we're going to go 2 units from one key point to the next. So there are 2. And since we bring it down here, we can see that. Now we'll call that the amplitude. So this is 3. Okay, so that looks like a 3 and a negative 3. So the absolute value of A is 3, but it has to be negative 3 for A itself, since this flips down here. Okay, so we're going to say that 2 pi divided by omega is equal to 8. So if I solve this for omega, we'll get omega is equal to 2 pi over 8. So that'll reduce to pi over 4. All right, so we've got the pieces. We know the amplitude is 3, but A has to be negative 3 because of this point down here instead of up here. So we're going to get y equals negative 3 times the sine of omega, which we know is pi over 4, times x. Okay, that's the graph that we were looking at here.